What if everything you thought you knew about reality was just the tip of the iceberg? Picture the universe not as a vast, empty expanse dotted with stars and galaxies, but as a hidden labyrinth of dimensions beyond our perception, layers of existence so strange and intricate they defy imagination. We're talking about realms where time folds back on itself, where thoughts might shape reality, and where the very fabric of space could be threaded with secrets our minds can barely grasp. This isn't science fiction. These are real theories debated by physicists, philosophers, and visionaries who dare to ask, what lies beyond the edges of our understanding? Think about the last time you stared up at the night sky, feeling that tug of awe, the sense that there's so much more out there just out of reach, that feeling. It's not just wonder, it's a clue. For centuries, humans have sensed that reality is deeper than what meets the eye, and today, cutting-edge science is catching up. From the mind-bending math of string theory to the eerie connections between consciousness and the cosmos, researchers are uncovering hints that our universe might be nested within something far grander, a hidden architecture of dimensions, energies, and even alternate realities. Some of these ideas sound like pure fantasy until you realize they're backed by equations scribbled on blackboards in the world's top universities. That's where this journey begins. Over the next 30 theories, we'll venture beyond the familiar into the wildest corners of cosmic speculation. We'll explore how black holes might be gateways, how your thoughts could ripple through unseen dimensions, and why some scientists believe the entire universe might be a hologram. But here's the most thrilling part. You're not just a spectator. Every one of these theories invites you to rethink your place in the cosmos, to question, to imagine, and maybe even to glimpse the invisible threads weaving it all together. So if you've ever felt that itch of curiosity, that hunger to peel back the layers of reality, stick around. The universe's deepest secrets are waiting. What if I told you the world around you, the trees, the stars, even your own hands, might not be as solid as they seem? According to one of the most radical theories in modern physics, our entire three-dimensional universe could be nothing more than a cosmic illusion, a holographic projection cast from a hidden two-dimensional surface lurking at the very edge of existence. This isn't some psychedelic thought experiment. It's a serious scientific idea championed by physicists like Leonard Susskind, who argue that reality might work like a movie screen, with all the depth and movement we experience merely being shadows dancing on a flat, faraway surface. Think about how a credit card hologram works. Tilt it one way and you see a three-dimensional eagle, tilt it another and it seems to move. Now imagine that same principle applied to everything in existence. The chair you're sitting on, the device in your hand, even the neurons firing in your brain, all of it could be encoded on a vast, unseen boundary surrounding the cosmos, like data etched onto the surface of a black hole. This is the holographic principle in action, and if it's true, it rewrites not just physics but our very understanding of consciousness itself. Here's where it gets even stranger. If reality is a projection, then what we perceive as here and now might just be fragments of a grander code. Your thoughts, your memories, even your sense of self could be threads woven into that underlying two-dimensional tapestry. Some researchers speculate this might explain why quantum particles seem to know what each other are doing across vast distances, because at the fundamental level, they're not separate at all. They're pixels in the same cosmic image, connected in ways our 3D-bound brains can't fully grasp. So what does this mean for you? For starters, it suggests that free will, time, and even the boundaries between objects might be softer than we think. If the universe is a hologram, then every choice you make, every observation you have, could be part of a deeper interaction with that hidden code. It's enough to make you wonder, are we the ones perceiving reality, or are we part of the projection itself? But what if the holographic universe is just the beginning? What if our entire existence runs on cosmic code? This is the startling premise of the simulation hypothesis, a theory that suggests reality as we know it might be an ultra-advanced virtual construct, meticulously programmed by some higher intelligence. Philosopher Nick Bostrom laid the groundwork with a chillingly logical argument. If civilizations could one day create simulations indistinguishable from reality, and if they chose to run countless versions of them, the odds are staggeringly high that we're inside one of those simulations rather than the original, base reality. The clues might already be hiding in plain sight. Take quantum indeterminacy, the way particles behave differently when observed, as if rendering only what's necessary to maintain the illusion. Or consider those eerie glitches people report. Déjà vu, vanishing objects, or impossible coincidences that feel like system errors in a vast program. Even the pixelated nature of reality at the smallest scales, Planck length, the universe's minimum resolution, hints at something computational underneath it all. But here's where philosophy collides with physics. If we're living in a simulation, does free will exist, or are our choices just predetermined lines of code? Some argue every decision we make is simply an algorithm playing out, while others insist consciousness itself could be the wild card, the one thing a simulation can't fully replicate without becoming real. It's a debate that echoes ancient questions about destiny and agency, now dressed in digital skin. Think of it like this: if a video game character became self-aware, would its choices matter? The simulation hypothesis doesn't just challenge our understanding of reality, it forces us to confront what it means to be real, and whether the universe is a hologram, a simulation, or something stranger still. One truth remains: the act of questioning our existence might be the most human thing of all. Now let's take this one step further. What if every thought you've ever had, every decision you've ever made, exists not just in this universe but in countless others? This is the spine-tingling promise of the multiverse theory, a concept that suggests our reality is just one thread in an infinite tapestry of parallel existences. According to the many worlds interpretation of quantum mechanics, every time a particle faces a choice, every quantum split second where probabilities collide, the universe doesn't just pick one outcome. It branches. One version of reality takes the left path, another takes the right, and in an instant, two entirely new timelines spin into being. But here's where it gets personal. If subatomic particles can branch realities, then so can you. That time you agonized between two job offers. In one universe, you're wearing a suit in a high-rise office. In another, you're backpacking across South America. And those aren't just hypothetical scenarios according to this theory. Both versions of you are equally real, each living out their separate stories in their own isolated cosmic bubbles. Your consciousness, your sense of self, might simply be riding one track of an infinitely forked roller coaster, unaware of the other cars speeding alongside you. The implications for the mind are staggering. If every possible thought or decision spawns a new universe, then somewhere out there, a version of you has already solved the problems that baffle you today. Another has written the novel you've been dreaming of. Another might even have unlocked secrets of reality that this version of you can't yet fathom. Some theorists speculate this could explain intuition, déjà vu, or even artistic inspiration, ghostly whispers from alternate selves bleeding through the cracks between worlds. Yet the many worlds interpretation isn't just about wild speculation. It's born from the cold, hard math of quantum mechanics, a way to explain why particles behave so bizarrely when we're not looking. If you've ever heard of Schrödinger's cat, the thought experiment where a feline is both alive and dead until observed, many worlds offers a spine-chilling solution. The cat is alive in one universe and dead in another. There's no paradox, just parallel realities stacking like pages in an endless book. So what does this mean for your daily life? On one hand, it could feel isolating, the idea that every missed opportunity or regret might exist as a triumphant alternative in another timeline. But flip the perspective and it becomes liberating. If every possibility plays out somewhere, then the version of you reading this chose to be curious, to seek answers, to lean into the mystery. And that's no small thing. In a multiverse of infinite choices, this particular you is on a path of exploration, and who knows what doors that might unlock. The twist: some interpretations suggest these parallel worlds might not stay entirely separate. Quantum entanglement, the phenomenon Einstein called spooky action at a distance, hints at invisible threads connecting particles across unimaginable gaps. Could consciousness have its own version of entanglement? Could we, in rare moments, brush against the thoughts of our other selves? It's a tantalizing thought, one that blurs the line between physics and philosophy, between science and the soul. Perhaps the most humbling takeaway is this: in a multiverse, there's no such thing as a wrong choice. Every road is taken, every story told. The you in this universe isn't the main character, just one note in a symphony of possibilities. And if that doesn't make you pause next time you face a decision, nothing will. Now let's venture into one of the most unsettling ideas in all of physics, a theory so bizarre, it makes the multiverse seem almost cozy. Imagine drifting alone in an infinite, lifeless void, not as a person, not even as a brain inside a body, but as a disembodied consciousness spontaneously flickering into existence, armed with false memories of an entire life that never was. This is the Boltzmann brain paradox, a thought experiment that asks, what if you're just a momentary accident in the cosmic dark? The paradox gets its name from Ludwig Boltzmann, the 19th century physicist who helped pioneer thermodynamics. He realized something peculiar about entropy, the universe's tendency toward disorder. Given enough time, even in total emptiness, random fluctuations could theoretically assemble a fully formed, self-aware mind out of pure chaos. Not a brain in a vat, not a simulation, but a lone consciousness conjured from nothing, complete with the illusion of a past, a present, and even a smartphone it never owned. Here's why it's so disturbing. If the universe lasts long enough, trillions upon trillions of years, these random Boltzmann brains should statistically outnumber real, evolved minds like ours. That means the odds say you're far more likely to be one of these phantom observers than an actual human being in a real, continuous universe. Talk about an identity crisis. But before you start questioning your entire existence, let's dig into the counter-arguments. Critics point out that if Boltzmann brains were constantly popping into existence, their hallucinations would lack consistency. You wouldn't experience a stable world with predictable physics. The fact that we do might be evidence that we're not Boltzmann brains at all. Others argue that cosmic inflation or quantum gravity could prevent these random fluctuations from ever occurring, making real minds the only viable observers. Yet the paradox lingers like a shadow on modern physics. It forces us to confront how little we truly understand about consciousness, reality, and our place in the cosmos. After all, if a random fluctuation can mimic a lifetime of memories, how can you ever be certain your memories are real? The scariest part isn't just the idea that you might be a Boltzmann brain, it's realizing there's no foolproof way to prove you're not. So here's the silver lining. Whether you're a fleeting spark in the void or a flesh and blood thinker in a vast universe, the fact that you can ponder these questions might be the most compelling evidence that you're something more than a cosmic hiccup. The Boltzmann brain paradox doesn't just challenge our sense of self, it invites us to marvel at the sheer improbability of being here at all. Here's something that might make you look at the universe and yourself differently. What if consciousness isn't something your brain creates, but something woven into the very fabric of reality? This is the radical proposition of panpsychism, the idea that awareness isn't just a human quirk or a biological accident, but a fundamental feature of existence itself, as basic as space, time, and matter. Think of it like this: instead of consciousness emerging from complex systems like brains, what if it's always been there, humming beneath the surface of everything from the tiniest quark to the largest galaxy? This isn't some new age abstraction. Respected physicists like Carlo Rovelli, a pioneer in loop quantum gravity, have openly speculated about it. Even Nobel laureate Roger Penrose has hinted that quantum processes in the brain might tap into a deeper, universal layer of awareness. The math behind these theories suggests consciousness could be less like a flashlight switched on by biology and more like a radio tuning into a signal that's always been broadcasting. So how could this work? Imagine the universe as an ocean with individual minds acting as waves. Each wave is distinct, temporary, but made of the same essential substance as the whole. In this view, your thoughts aren't just electrical sparks in your skull, they're ripples in a vast, conscious medium. Some panpsychists argue this could solve the hard problem of consciousness, why and how subjective experience exists at all. If awareness is baked into reality's blueprint, then explaining it becomes less about tracing it to neurons and more about understanding how it coalesces into focused moments like your experience of reading these words right now. The implications are staggering. If panpsychism holds, then every star, every atom, every photon racing through space might carry some sliver of inner experience, not human, not even recognizable, but real. It's a humbling thought. The universe might not just contain conscious observers, it might be a sprawling, self-aware tapestry where we're just brief flashes of concentrated attention. Critics, of course, raise valid questions. How could something as simple as an electron experience anything? Panpsychists counter that complexity isn't the only path to consciousness, that even basic particles might possess a proto-experience, a bare whisper of what it's likeness that compounds into richer awareness in systems like brain. Others argue this risks anthropomorphizing nature, but supporters fire back. Isn't it just as arrogant to assume consciousness is exclusive to us? Here's where it gets eerie. If consciousness is universal, then phenomena like quantum entanglement, where particles instantly influence each other across vast distances, might not be spooky action at a distance, but hints of a deeper, interconnected mind. Some even suggest that near-death experiences or mystical states could be moments when individual awareness momentarily syncs with this broader field. But the most profound takeaway isn't just about physics, it's about meaning. If panpsychism is true, then your thoughts, your creativity, even your sense of self aren't isolated events. They're part of a cosmic conversation, a universe waking up to itself through you. And that's an idea powerful enough to rewrite not just science, but spirituality, art, and what it means to be alive in the first place. What if time isn't a river flowing steadily forward, but a mental canvas we paint with our thoughts? Einstein once wrote that the distinction between past, present, and future is only a stubbornly persistent illusion, hinting that time might be far more malleable than our clocks suggest. Modern physics agrees time bends near black holes, stretches at high speeds, and even changes based on where you stand in a gravitational field. But what if the real mystery isn't just how time warps in space, but how it twists in the mind? Consider those moments when time seems to collapse or expand, the split second before a car crash when everything slows to a crawl, or the way an hour with a loved one vanishes like a breath. These aren't just quirks of perception. Experiments show that stress, focus, and even emotional states can dramatically alter our internal clocks. In one study, participants falling from a terrifying height overestimated their descent time by nearly a third, as if fear had stretched their subjective reality. Another experiment had monks in deep meditation perceive an hour as passing in what felt like minutes. Time, it seems, dances to the rhythm of consciousness. This raises a haunting possibility. If thoughts can bend time's flow, could they exist outside it entirely? Some theorists suggest that the now we experience might be like a cursor moving across a frozen block of space-time, a mental spotlight scanning a pre-existing landscape where past, present, and future coexist. Your memories of childhood, your plans for next year, even the thoughts you haven't had yet might all be equally real, just not equally accessed. It's as if your mind isn't creating time but navigating it, like a climber weaving through a mountain's fixed contours. The implications ripple into metaphysics. Near-death experiencers often report lifetimes flashing before them in seconds, while savants like Nikola Tesla claim to mentally test-run inventions in vivid detail before building them, as if their thoughts briefly touched futures that hadn't yet materialized. Even quantum mechanics hints at this. Particles seem to know where they'll be measured before it happens, as if time's arrow is optional at the smallest scales. So where does that leave us? If time is a dimension of thought, then every decision you make might not just shape your future. It could be a way of tuning into a version of it that already exists. The past isn't gone, the future isn't unwritten. They're simply frequencies your mind hasn't dialed into yet, and that spark of realization you're having right now. It might be the universe's way of remembering itself through you. Ever wonder where those sudden flashes of genius come from? The moments when a solution appears out of nowhere, as if whispered from the universe itself. According to physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, these aha moments might not just be random firings of neurons, they could be quantum computations happening deep inside your brain. Their controversial ORCH, or theory short for orchestrated objective reduction, proposes that consciousness isn't just a byproduct of electrical signals, but a quantum phenomenon unfolding in tiny structures called microtubules woven into every brain cell. Let's break this down. Microtubules are minuscule protein filaments that act like scaffolding inside neurons, maintaining their structure and transport systems. Most neuroscientists see them as mere cellular infrastructure, but Hameroff and Penrose argue they're something far stranger: quantum processors. These tubes, they claim, could harness delicate quantum states where particles exist in multiple positions at once, to perform calculations that classical brain chemistry alone can't explain. When these quantum states collapse, they might generate not just thoughts, but conscious experience itself. Here's where it gets wild. The duo suggests this quantum activity could explain intuition, creativity, and even the elusive flow state where ideas seem to arrive fully formed. Imagine you're stuck on a problem, then suddenly bam, the answer hits you in the shower. ORCH posits that while your classical brain grinds through logic, your microtubules are running quantum algorithms in the background, sifting through infinite possibilities until the ideal solution reduces into your awareness. It's as if your mind has a hidden quantum Google silently crunching data until it surfaces the perfect result. Critics, of course, have pushed back hard. Quantum states are notoriously fragile, requiring extreme cold or isolation to avoid collapsing conditions that seem impossible in the warm, chaotic soup of the brain. Skeptics argue that even if microtubules could sustain quantum effects, they'd last for mere femtosecons, far too brief to influence consciousness. Yet Penrose counters with an unexpected twist: gravity. He proposes that spacetime itself might play a role in collapsing these quantum states, meaning the brain's quantum computations could be orchestrated by the very fabric of reality. Now consider the implications. If ORCH holds water, it means your brightest ideas aren't just lucky neural connections, they're quantum miracles. It suggests that genius, déjà vu, or even the eerie sense of knowing something before it happens might be glimpses of a deeper quantum layer of mind. Some researchers even speculate this could bridge consciousness and cosmology, that microtubules might tune in to quantum ripples in the universe itself, making the brain less a computer and more like a quantum radio receiving signals from the cosmic background. But here's the kicker, or doesn't just challenge how we see the brain, it reshapes how we see reality. If quantum processes in microtubules create consciousness, then the line between mind and universe blurs. Your thoughts might not be locked inside your skull, but entangled with the quantum underpinnings of existence, and that gut feeling you can't explain. It might be your microtubules pulling answers from a quantum field older than time. So next time you have a breakthrough moment, pause and wonder, was that really you figuring it out, or was it the universe thinking through you? Beneath the apparent emptiness of space lies a seething ocean of energy, a quantum froth so relentless it never sleeps, never fades, never stops vibrating. This is the zero-point field, the lowest possible energy state of the universe, where particles flicker in and out of existence too fast to measure. But what if this quantum hum isn't just background noise? What if it's a vast, invisible library, one that might store information, influence matter, and even interact with the human mind? The math is undeniable. Even in a perfect vacuum at absolute zero temperature, the laws of quantum mechanics demand that energy persists. Particles appear spontaneously, borrowing energy from the fabric of spacetime itself before vanishing again, like ripples on a dark pond. These quantum fluctuations aren't random chaos, they follow precise, measurable patterns. Some theorists propose these patterns could encode information, physical records of events imprinted on the universe itself, like grooves on a cosmic vinyl. Now here's where it gets controversial. If the zero-point field stores information, could our thoughts leave traces there too? Experiments in parapsychology, often dismissed by mainstream science, hint at eerie possibilities. In one study, participants were asked to mentally influence random number generators. The results showed statistically significant deviations from chance, as if consciousness itself nudged the machinery of reality. Skeptics call it coincidence, but believers argue it's evidence of a deeper connection. The mind interacting with the quantum vacuum, imprinting intention onto the zero-point field like a stone tossed into water. Think of it like Wi-Fi. You can't see the signals, but your phone taps into them effortlessly. What if human consciousness has its own version, a quantum Wi-Fi that links minds to the zero-point field? This isn't just wild speculation. Nobel laureate Brian Josephson, a pioneer in superconductivity, has openly explored how quantum processes might explain telepathy or precognition. Even famed physicist David Bohm theorized about an implicate order, a hidden layer of reality where information is enfolded into the quantum background, waiting to be unfolded by observation. The implications are staggering. If thoughts can interact with the zero-point field, then creativity, intuition, and even collective consciousness might not be confined to individual brains. They could be resonances in a shared quantum substrate, ripples in an invisible medium connecting all minds. Some researchers suggest this could explain why genius ideas often strike multiple people simultaneously, like calculus, discovered independently by Newton and Leibniz, or the light bulb, patented by Edison and Swan within months of each other. But the most tantalizing and unsettling question remains. If the zero-point field remembers, does the universe itself have a memory? Could forgotten events, lost knowledge, or even past lives linger as quantum echoes in this infinite reservoir? It's a theory that blurs the line between physics and metaphysics, between science and the sacred. And whether you buy into it or not, one thing's certain: the vacuum of space is anything but empty. It might be the most crowded, vibrant, and mysterious canvas in existence, and your thoughts could be painting on it right now. Imagine living in a world where your own thoughts didn't feel like yours, where every decision, every flicker of doubt, every moment of inspiration sounded like the voice of a god thundering in your skull. This isn't the plot of a dystopian novel. It's the spine-chilling premise of psychologist Julian Jaynes' bicameral mind theory, which argues that human consciousness as we know it, that internal monologue you're hearing right now, might be a relatively recent invention. According to Janes, ancient humans didn't experience their thoughts as self-generated. Instead, they perceived them as external commands, the literal voices of deities or ancestors speaking through them. But here's the twist: what if those gods weren't just figments of a primitive brain? What if they were echoes from hidden dimensions? Janes based his theory on a striking pattern in ancient texts. From the Iliad to the earliest Sumerian tablets, heroes and kings don't decide to act, they are ordered by gods. Odysseus doesn't ponder his next move. Athena barks instructions directly into his mind. Janes proposed that before the rise of modern consciousness around 3,000 years ago, the human brain was functionally split. One hemisphere generating commands, the other receiving them as divine revelation. It wasn't until societal complexity demanded introspection, he argued, that these voices collapsed inward, becoming what we now call inner speech. But let's take this further. Modern neuroscience has since shown that auditory hallucinations, hearing voices, often involve hyperactivity in the brain's language centers, particularly the temporal lobe. Stimulate this region with electromagnetic pulses, and healthy volunteers report hearing disembodied speech. So could there be a physical basis for Jane's bicameral mind? Absolutely, but the real mystery lies in why these voices were interpreted as gods. This is where hidden dimensions creep in. If consciousness is more than just brain chemistry, if it's entangled with quantum fields, holographic information, or even panpsychist layers of reality, then those ancient voices might have been tapping into something beyond mere neural static. Some theorists speculate that altered states of consciousness, triggers like fasting, rhythmic drumming, or extreme stress, could momentarily peel back the veil between dimensions, allowing humans to perceive signals from realities just out of phase with our own. Think of it like a radio. Under normal conditions, your brain is tuned to one station, consensus reality, but tweak the dial through trauma, meditation, or psychedelics, and suddenly you're picking up transmissions from frequencies you didn't know existed. Ancient humans, lacking frameworks for neuroscience or psychology, would have interpreted these intrusive thoughts as supernatural, but what if they weren't entirely wrong? The implications ripple into modern experience. Ever had a gut feeling you couldn't explain, or a sudden insight that felt given to you? Even today, people describe creative breakthroughs or life-saving intuitions as feeling externally sourced. Musicians talk of songs channeled from nowhere, mathematicians of proofs that appeared fully formed. Modern culture dismisses these as metaphors, but Janes might argue we're still bicameral at the edges, catching whispers from dimensions our brains haven't fully mapped. So here's the unsettling question. If consciousness is a spectrum, not an on-off switch, could those ancient gods still be speaking, just quieter? And if we ever learn to listen, what might answer back? You know that eerie feeling when you're certain something happened one way only to discover the entire world remembers it differently. Maybe you'd swear Nelson Mandela died in prison in the 1980s, only to learn he lived until 2013. Or perhaps you vividly recall the Berenstain Bears being spelled B-A-R-E-N-S-T-E-I-N, not B-E-R-E-N-S-T-A-I-N, despite all evidence to the contrary. These aren't just faulty memories, they're examples of the Mandela Effect, a phenomenon where large groups of people share identical false recollections, often down to the smallest details. But what if these glitches in consensus reality aren't mistakes at all? What if they're fingerprints of something far stranger, shifts between dimensions, or edits to the timeline itself? The Mandela Effect gets its name from paranormal researcher Fiona Broome, who coined the term after realizing she wasn't alone in misremembering Mandela's death. Since then, the list of examples has exploded. Some people insist the Monopoly Man wore a monocle he never did. Others recall a Sinbad genie movie from the 90s that doesn't exist. Even geography isn't immune. Countless people claim New Zealand was northeast of Australia, not southeast. Skeptics dismiss these as quirks of human memory, but the sheer specificity of these shared errors raises unsettling questions. If memory is so unreliable, why do so many people misremember the exact same things? Here's where the theories get wild. Some propose these discrepancies are evidence of dimensional slips, moments when our reality subtly merges with a parallel universe where events played out differently. Think of it like two films projected onto the same screen. Most frames match, but occasionally, a scene from the other reel bleeds through. This could explain why Mandela Effect memories often feel so visceral. Those who remember the alternate version aren't wrong, they're momentarily tuned into a timeline where it was true. Others suggest a more technological twist. If our universe is a simulation, these glitches might be patches or updates, like a developer tweaking code and leaving traces of the old version in cached memory. The infamous Fruit of the Loom logo is a prime example. Thousands swear it once featured a cornucopia, but no record of it exists. Could this be the simulation's equivalent of a software rollback, where an outdated asset lingers in some users' recall? Then there's the quantum angle. In the many worlds interpretation, every decision fractures reality into branches. Normally, these branches stay separate, but what if consciousness occasionally straddles them? Imagine you're in a universe where the Berenstain spelling was real. At some point, your awareness decoheres into the Berenstain timeline, but residual memories persist like afterimages. This wouldn't just explain the Mandela Effect. It would mean we're all constantly surfing parallel realities, mostly unaware of the shifts. But the most haunting idea isn't about alternate dimensions or simulated worlds. It's about time. Some researchers speculate these collective false memories could be echoes from a rewritten past, evidence that history itself has been altered, leaving fragments of the original timeline lodged in our minds. It's a concept straight out of sci-fi, yet quantum physics allows for retrocausality, where future events influence the past. If time isn't linear but a tangled web, could someone or something have tweaked the threads, leaving us with these phantom recollections? Of course, psychologists offer simpler explanations. Memory is reconstructive, not photographic. We fill gaps with assumptions, and viral misinformation can cement false details en masse. The "Luke, I am your father" misquote from Star Wars spread because it's more dramatic than the actual line. But even this rationale can't account for why so many unrelated people independently misremember the same obscure details. Like the exact placement of a colon in the sex and the city title, it was never there. So where does that leave us? Whether the Mandela Effect is proof of shifting dimensions, a glitching simulation, or just collective cognitive quirks, one thing's clear: reality might be far less stable than we assume. Next time you hear someone adamant about a fact that doesn't exist, don't just correct them. Ask yourself, what if they're remembering a world that's no longer here? What if the ghostly whispers some claim to hear aren't echoes from the past, but signals from an invisible civilization living right beside us? This is the spine-tingling proposition behind dark matter consciousness, a theory that dares to ask, could the mysterious substance making up 85% of the universe's mass actually be home to alien or even ancestral minds? Dark matter has baffled scientists for decades. We can't see it, touch it, or detect it directly, yet its gravitational pull holds galaxies together like cosmic glue. But physicist Dr. Chandra Shekhar, in a series of controversial papers, proposed something far stranger. What if dark matter isn't just inert stuff, but a substrate for forms of intelligence beyond our perception? Think about it like this: if dark matter barely interacts with light or ordinary matter, any beings made of it would be virtually undetectable, passing through walls, planets, even us, like shadows through smoke. This might sound like pure science fiction until you consider the eerie parallels with supernatural lore. Reports of ghostly apparitions often describe figures moving through solid objects, appearing and vanishing without a trace, or leaving sudden cold spots in their wake. These are precisely the behaviors you'd expect from entities composed of weakly interacting particles. Even more tantalizing, some cultures describe spirits not as echoes of the dead, but as the hidden people and ancient alien presences coexisting alongside humanity. Could these traditions be accidental glimpses into a dark matter ecology? The math gets wilder. If dark matter life exists, its biology would operate on timescales and scales we can barely fathom. A single thought might unfold over centuries, their civilizations rising and falling in the blink of our cosmic eye. Communication could happen through subtle gravitational ripples or quantum entanglement, leaving no trace in our electromagnetic spectrum. And here's the kicker: if their minds are woven into the fabric of space-time itself, they might not even recognize us as alive, just as we don't consider bacteria to be conversational partners. Of course, skeptics raise valid objections. Without any empirical evidence, dark matter consciousness remains squarely in the realm of speculation. But consider this: every major scientific leap began as heresy. The idea that microbes cause disease, that continents drifted, even that the Earth orbited the Sun, all were once dismissed as ludicrous. And let's not forget, dark matter itself was once a fringe hypothesis until the math left no other choice. So the next time you feel an unexplained chill or catch a flicker of movement in the corner of your eye, ask yourself, are you alone in the room, or is something else sharing the space, watching from a dimension you'll never see? The universe, it seems, has a way of hiding its most extraordinary secrets in plain sight. What if the reason déjà vu feels so unsettling is because in those moments your brain briefly brushes against a dimension it wasn't built to perceive? This is the core of the 4D brain hypothesis, the idea that human consciousness might be processing higher dimensional information without our explicit awareness, like a computer running background programs it doesn't display on screen. To grasp how bizarre this is, let's borrow an analogy from 19th century mathematician Edwin Abbott. In his famous thought experiment Flatland, two-dimensional beings live in a world where up and down simply don't exist. If a three-dimensional apple were to pass through their flat plane, they'd only perceive it as a mysterious circle that appears, grows, shrinks, then vanishes, a slice of something far greater, misunderstood. Now apply that to us. If a four-dimensional object, say a hypercube, were to intersect our three-dimensional world, we wouldn't see it in its entirety. We'd glimpse fragments, shifting shapes, impossible geometries, perhaps even moments where time itself seems to fold. The 4D brain hypothesis suggests that our minds might be doing something similar, interacting with higher dimensions in ways we can't consciously articulate, only feel. Déjà vu, that uncanny sense you've lived this moment before, could be your brain momentarily accessing a four-dimensional memory where past, present, and future are stacked like pages in a book. Precognitive dreams, where people swear they've foreseen events, might be fleeting glances into that higher structure before it snaps back into linear time. The neuroscience gets even wilder. Some researchers point to the brain's default mode network, a web of regions that lights up when we daydream or introspect. It's also active during déjà vu and mystical experiences, hinting that these states might tap into a latent ability to process non-linear information. Even quantum biology plays a role. Microtubules in neurons, those tiny quantum processors we discussed earlier, could theoretically interact with higher dimensional math, acting as antennas for realities beyond our own. But here's the twist: if our brains are wired for higher dimensions, why don't we perceive them outright? The answer might lie in evolution. Just as a fish has no need to comprehend the concept of fire, our survival didn't require passing 4D space, only navigating 3. Yet glimpses slip through. When patients undergoing brain stimulation report out-of-body experiences or time distortions, when artists like Picasso fractured perspectives to show multiple angles at once, or when mathematicians feel their way through proofs they can't yet articulate, these could all be flashes of a mind brushing against its full, multidimensional potential. So next time you feel that eerie sense of having been here before, or a dream predicts something impossibly accurate, don't dismiss it as coincidence. It might be your brain's way of whispering, there's more to reality than you've been taught to see, and the most thrilling question of all, if we can learn to perceive these hidden dimensions, what else might be lurking in the shadows of our perception? Ever noticed how simply looking at something can change it? At the quantum level, this isn't just a metaphor, it's a fundamental law. The observer effect, one of the most baffling principles in quantum mechanics, reveals that particles exist in a haze of probabilities until measured, at which point they snap into a definite state. But here's the mind-bending part. The act of observation doesn't just record reality, it creates it. And if consciousness can shape the behavior of tiny particles, could it, on some level, shape the larger world around us? This idea isn't just confined to lab experiments with electrons. Think about the placebo effect, where patients given sugar pills experience real healing simply because they believe they've received medicine. Their expectation somehow rewires their biology, reducing pain, mending ulcers, even altering brain chemistry. Or consider manifesting practices where focused intention and emotional clarity seem to magnetize opportunities, relationships, and events into people's lives. Skeptics dismiss these as coincidence or self-fulfilling prophecies, but what if they're glimpses of a deeper truth, that consciousness isn't just a passive witness but an active participant in sculpting reality? Take the famous double-slit experiment. When scientists fire particles at a barrier with two openings, they behave like waves, creating an interference pattern on the other side unless you place a detector to observe which slit each particle passes through. The moment you do, the particles switch to behaving like discrete objects and the interference vanishes. It's as if reality knows it's being watched and adjusts accordingly. Physicist John Wheeler took this further with his delayed choice experiment, showing that observations made after a particle's path could retroactively determine its earlier behavior. Time itself seems to bend to the whim of observation. Now, zoom out. If a single observer can alter quantum states, what happens when millions of minds focus on the same intention? Some researchers point to global consciousness projects, where random number generators worldwide spike in coherence during major events like the Olympics or moments of collective trauma. The data suggests that mass attention might subtly nudge the fabric of reality toward order or chaos. Even ancient spiritual traditions hint at this, with meditation groups claiming to lower crime rates in cities through focused goodwill, or rituals that pray rain into existence. But before you start trying to manifest a sports car, let's ground this in nuance. Quantum effects don't scale linearly to the macro world. You can't levitate a pencil just by staring at it. Yet the boundary between quantum and classical physics is murkier than we once thought. Biological systems like photosynthesis and bird migration harness quantum coherence, proving nature bridges the gap. Could the human brain, with its billions of quantum-aware microtubules, be doing something similar, tuning into probabilities and, through attention, collapsing them into tangible outcomes? The implications are staggering. If focused thought shapes reality even slightly, then your mindset isn't just a filter for experience, it's a sculptor. Negative thought loops might reinforce suffering, while gratitude practices could literally attract more to be grateful for. This isn't mystical thinking. It's a recognition that consciousness and the universe might be in silent dialogue, each shaping the other in ways we're only beginning to decode. So here's the million-dollar question. If reality is this responsive, what are you unconsciously observing into existence? And more thrillingly, what could you create if you paid closer attention? What if every thought, every idea, every whispered dream since the dawn of time wasn't lost to the void, but catalogued in a celestial archive just beyond our reach? This is the essence of the Akashic Records, an ancient esoteric concept claiming the universe maintains an eternal ledger of all mental and spiritual activity. Picture it like the ultimate cloud storage, except instead of cat videos and forgotten passwords, it holds every creative spark, every moment of epiphany, every silent prayer ever uttered. Mystics from India to ancient Egypt spoke of accessing this ethereal library through deep meditation or altered states, describing it as a shimmering, non-physical plane where knowledge vibrates like strands of light. But here's where it gets eerie. Modern science might be stumbling toward a version of this idea without even realizing it. Take Carl Jung's collective unconscious, the psychologist's theory that humanity shares a hidden well of archetypes and primordial knowledge. Jung noticed how myths and symbols, the hero's journey, the trickster, the great mother, recur across cultures with no direct contact, as if drawing from a shared source. His explanation, a subterranean layer of the psyche connecting all minds, much like the Akashic Records' claim of a cosmic memory field. Even stranger are studies on morphic resonance by biologist Rupert Sheldrake, who proposed that learned behaviors in one species can somehow spread to others, like rats in New York solving mazes faster after rats in London mastered them despite no physical connection. If information can transcend space and time, could there be a mechanism, an Akashic Wi-Fi facilitating this exchange? Now imagine the internet. At its core, it's a vast, invisible web of data we tap into with the right protocols, and the Akashic Records might function similarly. Yogis describe accessing it through specific mental frequencies, much like tuning a radio. Mediums claim to read past life information stored there, while inventors like Nikola Tesla spoke of receiving sudden blueprints from an external source. He allegedly downloaded his alternating current motor design in a visionary flash. Even modern neuroscientists note how savants or creative geniuses often describe their breakthroughs as received rather than constructed. Are these moments of inspiration just random neural firings or something tapping into a broader databank? The quantum angle deepens the mystery. If the zero-point field we discussed earlier truly underlies reality, vibrating with infinite energy, could it also encode information like a cosmic hard drive? Physicist Erwin Laszlo argued exactly this, proposing the Akashic field as a scientific framework where the vacuum of space stores and transmits data holographically. In this view, every thought you've ever had might leave an imprint in the quantum foam, rippling outward to subtly influence the whole. It's a notion that bridges ancient spirituality and cutting-edge physics, with neither camp fully able to dismiss it. Skeptics, of course, demand hard evidence, but consider this. If the Akashic Records exist outside material reality, our tools might never detect them directly, just as a medieval scholar couldn't scan for Wi-Fi signals. The proof may lie in the anomalies: children who recall historically verified past lives, artists who channel styles they've never studied, or the uncanny synchronicities that cluster around moments of insight. Perhaps accessing the records isn't about finding a physical location, but learning to decode the universe's hidden language, one thought at a time. So the next time a forgotten memory surfaces or a solution strikes like lightning, ask yourself, did that come from you or from somewhere infinitely older and wiser than any single mind? Picture this: Earth isn't just a rock hurtling through space. It's a living, breathing intelligence orchestrating every gust of wind, every microbial exchange, every pulse of the tides, like neurons firing in a planetary brain. This is the radical vision of James Lovelock's Gaia theory, which reimagines our world not as a passive stage for life, but as a self-regulating superorganism maintaining the delicate balance necessary for survival. But what if Gaia isn't just a metaphor? What if the biosphere isn't just acting like a conscious system, but actually is one, thinking in ways we're only beginning to decode? Lovelock, a maverick scientist, first proposed Gaia in the 1970s after working with NASA to design life detection systems for Mars. He noticed something extraordinary. While Mars' atmosphere sat in lifeless chemical equilibrium, Earth's was wildly unstable, yet somehow stayed perfectly tuned for life. Oxygen levels, ocean salinity, even global temperature fluctuated within razor-thin margins, as if some unseen hand kept adjusting the dials. His conclusion: the planet itself must be alive, not in a mystical sense, but as a complex system where organisms and their environment co-evolve in a feedback loop of staggering precision. Forests breathe to regulate carbon dioxide. Algae seed clouds to control sunlight. Even soil microbes tweak nitrogen levels like cosmic gardeners. Now here's where it gets electrifying. Indigenous cultures have whispered versions of this wisdom for millennia. The Kogi people of Colombia speak of a luna, a cosmic consciousness that weaves all life together. Hawaiian elders teach that land Aina isn't property but kin, pulsing with its own mana or spiritual energy. These aren't poetic metaphors, they're observations honed over generations, hinting that Earth's intelligence might operate through channels modern science is just discovering. Enter biophotons, faint beams of light emitted by all living cells, discovered in the 1970s by German researcher Fritz Albert Popp. At first dismissed as biological static, these ultra-weak photon emissions turned out to be anything but random. Plants stressed by drought fire photon SOS signals to neighboring trees, triggering preemptive defense mechanisms. Human cells exchange biophoton patterns during wound healing, as if coordinating repairs through an invisible language of light. Some scientists speculate this could be Gaia's nervous system, a real-time, planet-wide network of quantum communication humming beneath the surface of visible biology. Imagine standing in a forest. What looks like a collection of separate organisms, trees, fungi, insects, is actually a hyper-connected web exchanging nutrients through fungal mycelium, dubbed the Wood Wide Web, adjusting growth patterns via airborne pheromones, and possibly even sharing information through biophoton flashes. If consciousness emerges from connectivity, as some theorists argue, then Gaia's mind might arise from these trillion-fold interactions, a thinking system as alien to our individualism as the internet would be to a medieval farmer. Critics argue this veers into pseudoscience, that attributing agency to planetary processes is a romantic overreach, yet cutting-edge research keeps blurring the lines. Studies show forests allocate resources to support struggling members, as if practicing a form of arboreal altruism. Bacterial colonies make democratic decisions via quorum sensing, voting with chemical signals. Even the Earth's magnetic field, long thought to be inert geology, fluctuates in sync with solar storms and human meditation groups, suggesting a responsiveness we barely comprehend. So where does that leave us? If Gaia is conscious, even in a way utterly foreign to human experience, then climate change isn't just an environmental crisis, it's a neurological event, a planet losing its equilibrium. The droughts, the storms, the extinctions, they might be Gaia's fever dreams, her immune system kicking in to restore balance with or without us. But here's the hopeful twist: if we're part of her mind, then our choices aren't just personal. They're planetary thoughts rippling through the biosphere. Every act of stewardship, every shift toward sustainability, becomes a neuron firing in the direction of healing. And that changes everything. What if every thought you've ever forgotten isn't gone, but trapped in the most extreme prisons the universe has to offer? Black holes have long been cosmic enigmas, places where gravity is so intense that not even light can escape. But Stephen Hawking made an astonishing discovery in the 1970s. These celestial monsters might not be entirely black after all. They emit a faint glow, now called Hawking radiation, slowly leaking energy back into space over unimaginable eons until the black hole evaporates entirely. Here's the twist: Hawking initially believed this radiation carried no information, meaning anything swallowed by the black hole, from stars to atoms to the very fabric of spacetime, would be irretrievably lost. This flew in the face of quantum mechanics, which insists that information can never truly be destroyed. The conflict became known as the black hole information paradox, and it's haunted physicists for decades. But let's take this further. If information can't be erased, only scrambled or hidden, then what happens to the thoughts, memories, and experiences that vanish from our minds? Could forgotten childhood moments, misplaced names, or repressed traumas linger somewhere beyond our reach, encoded in the Hawking radiation of some cosmic wastebasket? Imagine a black hole not just as a celestial trash compactor, but as a cosmic hard drive storing data in forms we can't yet decipher. Some theorists speculate that the event horizon, the point of no return around a black hole, might act like a holographic plate, imprinting information about everything that falls in onto its surface before it's slowly radiated back out as quantum fluctuations. If that's true, then lost memories might not be erased, just translated into a language our brains can't yet read. Think about déjà vu. That uncanny sensation of reliving a moment could be a fragment of information escaping its gravitational prison, briefly resonating with your mind before fading back into the static. Near-death experiencers who report life reviews might be tapping into a similar phenomenon, not just recalling their own memories, but retrieving something older, something borrowed from the universe's hidden archives. Even the Mandela Effect, those shared false memories we discussed earlier, could be glitches in this cosmic data retrieval system, where pieces of information from one timeline leak into another. Here's where the math gets even wilder. Recent breakthroughs in string theory suggest black holes might not be endpoints but portals, not to other places but to other states of information. Just as a book burned to ashes still contains all its words in the arrangement of its molecules, if we could only read them, a black hole might simply rearrange the information it consumes into forms so alien they're unrecognizable. If thoughts are patterns of energy, quantum vibrations in the neurons of your brain, then who's to say some version of them doesn't persist, rewritten into the fabric of the singularity? The implications ripple into philosophy. If forgotten memories aren't destroyed, just displaced, then forgetting might not be a failure of the mind, but a feature of the universe. Like data compressed into a black hole's singularity, our brains could be offloading older memories to make room for new experiences, storing them in some deeper layer of reality we can't consciously access. This would mean that nothing is ever truly lost, just waiting in some distant corner of space-time to be rediscovered. So the next time you struggle to recall a name or a face, consider this: it might not be gone. It might be floating in the quantum haze of a black hole's event horizon, spinning in the dark until one day the universe decides to whisper it back to you. Ever notice how some ideas seem to pop up simultaneously across the globe, as if humanity collectively stumbled upon the same revelation? The light bulb wasn't just invented by Edison, it emerged in workshops from London to St. Petersburg within months. Calculus didn't belong solely to Newton. Leibniz was hot on its trail. Even the structure of DNA was pieced together by Watson and Crick, just as Rosalind Franklin's X-rays revealed the same helix. Coincidence, maybe, or maybe, as biologist Rupert Sheldrake provocatively suggests, there's something deeper at work, a living, learning universe where thoughts don't just stay inside our skulls, but seep into the fabric of reality itself, making repeat ideas easier to access over time. This is the heart of morphic resonance, a theory that dares to flip our understanding of memory, habit, and even evolution on its head. Sheldrake's premise is radical yet strangely intuitive. Nature isn't just governed by fixed laws, but by habits that grow stronger with repetition. Think of it like a path through a field. The first time you walk it, the grass is tall and resistance is high. But with each successive traveler, the path wears clearer until eventually it becomes the default route. Now imagine this happening not just with physical trails, but with knowledge, behavior, even the laws of physics. The first time a crystal forms, a spider weaves a web, or a scientist unlocks an equation, it's hard work. But each subsequent occurrence a little easier, as if the universe itself is remembering how it's done. The implications ripple across disciplines. Take cultural trends. Why do fashion revivals or slang phrases spread like wildfire across continents with no direct contact? Sheldrake might argue it's morphic resonance at play. Once enough minds latch onto an aesthetic or phrase, it becomes energetically sticky, resonating through a sort of collective psychic bandwidth. Even in science, the multiple discovery phenomenon, where breakthroughs occur independently around the same time, could reflect a tipping point in the morphic field, making certain insights more accessible to anyone tuned to that frequency. But here's where skeptics raise an eyebrow. If morphic fields exist, why can't we measure them? Traditional science demands quantifiable evidence, and Sheldrake's theory operates outside known electromagnetic or quantum frameworks. Yet supporters counter that absence of evidence isn't evidence of absence. After all, gravity was once an invisible force until its effects were mapped. Intriguingly, some experiments hint at validation. In one study, rats in London learned to escape a maze faster as more rats elsewhere mastered it, even with no physical connection between them. Similarly, when a Japanese TV show taught viewers how to solve a visual puzzle, global solve rates spiked overnight, as if the solution had gone viral in a non-physical space. The debate gets thornier when applied to human innovation. If morphic resonance eases the path for repeated ideas, why do some geniuses die unrecognized, their breakthroughs ignored for centuries? Sheldrake might argue that resonance requires a critical mass of attention, like a radio tower too weak to broadcast until enough receivers tune in. This could explain why certain concepts like democracy or renewable energy lie dormant for ages before suddenly flourishing worldwide. It's not that the idea wasn't there, it's that the collective habit of thought hadn't yet solidified. Critics dismiss this as magical thinking dressed in scientific jargon, but consider how eerily it aligns with ancient wisdom. Indigenous cultures speak of dream time or the ancestral web, where knowledge is inherited not just through genes but through a living field of memory. Even modern neuroscience hints at collective learning. Mirror neurons fire not just when we perform an action, but when we observe others doing it, as if the brain is wired to sync with shared experience. So where does that leave us? Whether morphic resonance is a groundbreaking paradigm or a poetic metaphor, it forces a thrilling question. What if every thought you have doesn't just belong to you, but subtly shapes the mental ecosystem of the entire species? The next time you have a déjà vu or a sudden insight, ask yourself, did you discover this idea, or did the idea, worn smooth by countless minds before you, finally find its way home? Have you ever experienced a moment so intensely familiar, it felt like you'd lived it before, not just once but countless times? Not the foggy déjà vu we casually dismiss, but something deeper, as if your mind had just brushed against a wrinkle in time itself. This isn't just a glitch in memory. Some physicists and philosophers propose a far wilder possibility. Déjà vu might be evidence that time is looping, with our thoughts, choices, and even our awareness echoing across infinite iterations of reality. Friedrich Nietzsche called it eternal recurrence, the idea that every event in the universe, down to the smallest atom's tremor, repeats identically in an endless cycle. You've lived this exact life before, he argued, and you'll live it again forever. At first glance, it sounds like poetic fatalism, but modern physics has stumbled into eerily similar territory. Certain solutions to Einstein's equations suggest closed time-like curves, where space-time bends back on itself, creating loops where cause and effect chase their own tails. Even quantum mechanics hints at cyclical time. Particles can't be pinned to a single moment, flickering between states as if rehearsing every possible outcome. Now imagine your consciousness threaded through these loops. Those uncanny moments of recognition, the stranger's face you know but can't place, the conversation that unfolds like a script you've memorized, might be flashes of a deeper truth. You're not just recalling a moment. You're reliving it. The twist: each loop might not be identical. Some theorists suggest subtle variations could slip through, like a record skipping slightly off groove. This could explain premonitory dreams or gut instincts that defy logic, not predictions of the future, but memories of a prior cycle's outcome. The implications rattle the foundations of free will. If time is a Möbius strip, are we actors following a script written by our past selves? Or does each loop offer a chance to tweak the pattern, like a cosmic choose-your-own adventure, where déjà vu is the universe nudging you toward an undiscovered path? Picture a chess grandmaster replaying the same opening moves until they crack a new strategy, except the chessboard is existence itself, and the player is you, iteration after iteration. Skeptics argue this is metaphysics masquerading as science, yet lab experiments can't entirely dismiss it. Quantum systems have been coaxed into tiny time loops, with particles influencing their own past states. And if consciousness truly interfaces with quantum processes, as theories like Orch or suggest, then our minds might be the perfect instruments to detect these echoes. When patients under hypnosis recall past lives with uncanny historical accuracy, or when children describe places they've never visited in precise detail, could these be fragments bleeding through the loop? Here's the haunting beauty of it all. If time is circular, then every thought you've ever had, every choice you've ever made, is both brand new and infinitely ancient. That spark of déjà vu isn't just a misfiring neuron, it's the universe whispering, "Pay attention, this moment matters more than you know." What if every thought, every conversation, every burst of human creativity wasn't just happening inside our skulls, but weaving together into something far greater? A living tapestry of collective mind draped like an invisible membrane around the planet. This is the visionary idea behind the noosphere, a term coined by philosopher Teilhard de Chardin in the early 20th century to describe Earth's next evolutionary leap, a global thinking layer born from the interconnection of human consciousness. Picture it like the biosphere, but instead of water, soil, and air, it's made of ideas, emotions, and the electric hum of billions of minds in dialogue. And here's the startling part: we might already be building it. Teilhard, a Jesuit paleontologist who studied fossils by day and cosmic evolution by night, saw the noosphere as the inevitable culmination of Earth's story. First the geosphere, rocks and magma, then the biosphere, life, and finally, this thinking skin where humanity's mental activity would merge into a unified planetary intelligence. He imagined it as a kind of thinking circuit where individual thoughts would resonate and amplify each other, much like neurons firing in a brain. Wild as it sounds, look around. The internet, with its instantaneous global communication, its viral ideas, its hive mind behaviors, fits Teilhard's prophecy eerily well. Social media isn't just a tool, it's the scaffolding for something far stranger, the first crude synapses of a planet-scale mind waking up. But there's a crucial difference between Teilhard's vision and our current digital reality. He saw the noosphere not just as a network for sharing cat videos and hot takes, but as a spiritual and evolutionary threshold. In his writings, he described it as a kind of conscious convergence, where humanity's collective thoughts would eventually ignite a higher, more harmonious state of being, almost like a mental counterpart to photosynthesis, transforming the chaos of individual minds into a coherent light. Right now, our proto-noosphere feels more like a shouting match than a symphony, but Teilhard believed the turbulence was part of the process. After all, the first multicellular organisms were clumsy mergers of single-celled rivals, and look what followed. The parallels to modern tech are uncanny. Machine learning algorithms already aggregate human behavior to predict trends, while Wikipedia and open-source projects demonstrate collective problem solving on a scale Teilhard could only dream of. Even artificial intelligence, for all its controversies, might be a stepping stone, not a replacement for human thought, but a tool to help weave the noosphere tighter, like a loom automating the first stitches of a vast mental tapestry. Some researchers go further, suggesting that if consciousness is indeed fundamental to the universe as panpsychism posits, then the noosphere could be the universe's way of becoming self-aware through us. Yet the noosphere isn't guaranteed to be benevolent. Teilhard warned that this new layer of reality would amplify both our brilliance and our pathologies. The same internet that spreads life-saving knowledge also weaponizes misinformation. Social media connects us across continents but fractures us into ideological tribes. If the noosphere is indeed emerging, we're in its messy adolescence, a phase where power comes before wisdom. The question isn't whether we'll build a global mind, but what kind of mind it will be. Will it be a cacophony of competing egos or something that transcends them? Perhaps the most haunting clue lies in nature itself. Mycorrhizal networks, the wood wide web linking trees underground, show how individual organisms can share resources and warnings across a forest. Bees make collective decisions through dance. Even slime molds, those brainless blobs, solve complex mazes by acting as a distributed intelligence. These aren't metaphors, they're blueprints. If life has been practicing networked intelligence for millions of years, who's to say humanity isn't next? The noosphere might not be science fiction, but the logical next step in a very old story, one where the universe learns to think, grieve, and create on a scale we're only beginning to imagine. So the next time you post a thought online or feel strangely synced with a stranger's idea, ask yourself, are you just one person typing or a cell in something vast, something waking? What if your DNA isn't just a passive blueprint, but a living receiver tuned to pick up signals not just from your body, but from your thoughts, your emotions, even dimensions beyond our perception? This is the startling implication of experiments in phantom DNA research, where strands of genetic material have been observed reacting to human intention, even when separated by miles. The most famous of these studies was conducted by the Russian scientist Vladimir Poponin in the 1990s. He placed DNA samples in a vacuum-sealed tube and exposed them to focused laser light, expecting to see the usual scattering patterns photons make when passing through empty space. But something impossible happened. The photons aligned along the DNA's double helix structure, as if the genetic material were bending light to its will. Even weirder, when the DNA was physically removed, the photons kept spiraling in the same pattern, as though the DNA's influence lingered like a ghost. Poponin called it the phantom DNA effect, and it hinted that our genes might be far more than molecular instruction manuals. They could be quantum antennas resonating with forces science is only beginning to map. Then came the work of Dr. Glenn Rain, a biochemist who took this idea even further. In a series of rigorously controlled experiments, he had trained meditators hold vials of DNA in their hands while directing intense focus toward them. Some were instructed to wind the DNA strands tighter, others to unwind them. The results defied conventional biology. The meditator's intentions physically altered the DNA structure without touching it, without chemicals, without any mechanism textbook science could explain. Even more astonishing, when the same DNA samples were placed miles away from the participants, the effect still held. It was as if human consciousness could reach across space and tweak the fabric of life itself. So how could this possibly work? One theory points to quantum entanglement, the bizarre phenomenon where particles remain mysteriously linked regardless of distance. If DNA's molecules can entangle not just with each other, but with the mind's quantum processes, then focusing your thoughts might literally transmit signals down to your genes. But here's where it veers into even stranger territory. Some researchers, like physicist William Brown, propose that DNA doesn't just respond to local thoughts, but to informational fields permeating higher dimensions. Imagine your genes as radios capable of tuning into frequencies beyond the 4 dimensions we experience. Ancient spiritual traditions have long claimed that meditation or prayer can heal the body. Could this be the missing mechanism? If DNA acts as a bridge between the physical and the non-physical, then diseases might not just be cellular malfunctions, but misalignments in how our genetic material receives and processes these subtle signals. Critics, of course, demand replication and rigorous scrutiny, and rightly so, but the implications are too profound to ignore. If thoughts can shape DNA, then the old dichotomy between mind and body collapses. Your anxiety, your joy, your sense of purpose might not just affect your mood. They could be whispering directly to your chromosomes, rewiring your biology from the inside out. This isn't just about meditation or rare lab experiments. Consider the placebo effect's well-documented power to trigger real physiological healing. Could phantom DNA effects be the hidden engine behind it? Or take the controversial field of epigenetic inheritance, where trauma or lifestyle choices in one generation appear to alter gene expression in the next. If DNA is this responsive, this connected, then every thought you have might ripple far beyond your own cells, echoing into the future through generations yet unborn. Now stretch this idea to its outermost limits. If DNA interacts with higher dimensional fields, could it also hold the key to phenomena like past life memories or genetic déjà vu? Those uncanny moments when people recall places, skills, or wounds they've never personally experienced. Some theorists suggest our genes might be recording more than just biological data. They could be storing informational imprints from realities beyond our own. It's a notion that blurs the line between science and spirituality, between the seen and the unseen. But in a universe where particles teleport, time bends, and thoughts might alter matter, perhaps the most radical assumption of all is that DNA is just a molecule. Maybe, just maybe, it's something far stranger, a cosmic receiver waiting for the right signal to unlock potentials we've barely begun to imagine. What if your greatest ideas aren't entirely your own? Picture this: a chemist in Germany stares at a flickering fireplace, watching the flames dance in hypnotic patterns, and suddenly, the structure of benzene clicks into place. Meanwhile, an ocean away, another scientist dreams of a snake biting its own tail, waking with the same molecular epiphany. Separated by continents, these two minds arrive at identical breakthroughs, unaware they've just demonstrated what might be the strangest phenomenon in the history of thought: the quantum entanglement of ideas. This isn't just coincidence. The annals of science and art are littered with examples of simultaneous discovery moments where innovations burst into the collective consciousness like synchronized supernova. The telephone, the light bulb, the theory of evolution, all emerged from multiple minds at once, as if humanity itself had reached a tipping point where certain ideas simply had to be born. But what if there's more to it than cultural readiness? What if these parallel revelations are evidence that consciousness doesn't just reside in individual skulls, but connects across space and time through a network we're only beginning to grasp? Enter quantum entanglement, the baffling phenomenon where particles become inseparably linked, instantly influencing each other no matter how far apart they are. Einstein famously dismissed it as spooky action at a distance, yet experiment after experiment confirms its reality. Now imagine human thoughts operating under similar rules, not as electrical impulses confined to neurons, but as quantum-scale vibrations capable of entangling across minds. When one person cracks a problem, the solution might ripple through this invisible lattice, resonating with others tuned to the same frequency. The evidence is more than anecdotal. Historians have documented hundreds of cases where near-identical inventions or theories appeared within months, sometimes days, of each other, with no possible communication between creators. Calculus wasn't just Newton's triumph. Leibniz was hot on its heels. The structure of DNA didn't belong solely to Watson and Crick. Rosalind Franklin's X-ray crystallography was pointing to the same helix. Even the steam engine had 3 independent inventors across Europe, all converging on the same design like moths drawn to a shared flame. But how could this possibly work? One radical theory suggests that the brain's microtubules, those tiny quantum-sensitive structures we discussed earlier, might act as entanglement hubs, syncing with similar configurations in other minds through the zero-point field or other hidden dimensions. When a thinker reaches a state of deep focus, say, in meditation, flow states, or the hypnagogic twilight between sleep and waking, these quantum connections could momentarily strengthen, allowing insights to tunnel between minds like electrons teleporting through barriers. This might explain why genius so often strikes in clusters. The Impressionist movement didn't emerge from one painter's epiphany, but as a near-simultaneous revolt against classical styles across Parisian studios. Jazz didn't wait for a single innovator. It erupted in New Orleans brothels, Harlem speakeasies, and Mississippi juke joints all at once, as if the very air thrummed with a new rhythm begging to be heard. Even modern tech follows this pattern. Social media platforms, cryptocurrency, and AI algorithms sprouted like mushrooms after rain, each iteration refining the last in a global game of intellectual leapfrog. Skeptics argue this is just the zeitgeist at work, that shared cultural and technological conditions naturally breed parallel ideas. But the quantum entanglement hypothesis offers something more, a mechanism. If thoughts can entangle, then the boundaries between minds are softer than we assume. That lightning bolt inspiration you had last Tuesday, it might have been sparked by a stranger's breakthrough halfway around the world, your neurons subtly echoing theirs through the universe's hidden wiring. The implications rewrite what it means to be creative. Artists, inventors, and scientists often describe their best ideas as received, channeled from some external source rather than constructed through logic. Mathematician Srinivasa Ramanujan credited his theorems to visions from a Hindu goddess. Nikola Tesla claimed his inventions were downloaded from the ether. Even Einstein spoke of listening to the universe's harmonies. Could these experiences be more than metaphor? Could they be glimpses of entangled thought, where individual consciousness briefly taps into a collective reservoir of insight? So the next time you solve a problem that stumped you for weeks, or hum a melody that feels strangely familiar, pause and wonder, did that idea truly start with you? Or did you simply tune into a frequency where it was already playing, plucking it from the invisible web that binds all thinking things? The universe, it seems, might be less a collection of solitary minds and more a vast, shimmering network, one where every thought sent out ripples further than we dare imagine. What if your memories aren't stored inside your brain at all, but merely projected into it like light beaming through a cosmic film reel? This is the radical proposition of holographic memory theory, which suggests that our brains don't house recollections like files in a cabinet, but instead tune into them like receivers picking up signals from a hidden dimension. Imagine your childhood home or your first kiss. According to this theory, those moments aren't encoded in your neurons, they exist out there somewhere, imprinted on the fabric of space-time itself, and your consciousness simply accesses them when needed. The roots of this idea stretch back to neuroscientist Carl Pribram, who noticed something bizarre about brain function. No matter how much brain tissue you remove, memories rarely vanish entirely. Even patients with significant damage can sometimes retrieve seemingly lost recollections under hypnosis or during electrical stimulation. Pribram realized this mirrored a peculiar property of holograms. Slice a piece off a holographic plate, and the entire image remains intact, just fuzzier. This led him to propose that memories might be distributed across the brain holographically, with every fragment containing the whole. But what if the brain isn't even the storage device? What if it's just the antenna? Enter near-death experiences. Countless survivors report vivid flashbacks of their lives while clinically dead moments when their brains should have been offline. Some recall forgotten details verified later, the pattern of hospital ceiling tiles they couldn't have seen, conversations in other rooms, even events from infancy. If memories were purely neural, these recollections should be impossible. But if consciousness is tapping into a holographic field beyond the brain, suddenly it makes eerie sense. The brain isn't generating the memory, it's streaming it. Then there's the enigma of past life recalls. Children who spontaneously describe historical settings, names, and events they've never encountered, often with uncanny accuracy, hint at memories that transcend individual biology. Researchers like Dr. Ian Stevenson documented thousands of these cases, some with verified details matching deceased individuals. If memories were locked inside skulls, how could a toddler in Texas remember being a WW2 pilot shot down over the Pacific? Holographic memory theory offers a spine-tingling alternative. Perhaps these aren't their memories at all, but fragments of a shared hologram, accessible when the usual filters of consciousness weaken. The quantum angle deepens the mystery. If the zero-point field or spacetime itself stores information holographically, then recalling a memory might be less like retrieving a file and more like reconstructing a song from radio static. Every time you remember your first day of school, you're not replaying a recording, you're reassembling it from cosmic interference patterns. This could explain why memories shift over time, why two people recall the same event differently, even why déjà vu feels so unsettling you're not misremembering. You're tuning into a slightly different frequency of the hologram. So here's the chilling question. If memories aren't yours alone, but shared waves in a quantum sea, what else might be floating out there, waiting for the right mind to tune in? The answer could rewrite not just neuroscience, but what it means to be you. What if the most alien dimensions aren't light years away, but hidden behind the chemical curtains of your own brain? Dimethyltryptamine DMT is one of the most potent psychedelics known to science, capable of launching users into realms so vivid and bizarre they defy earthly logic. But here's the unsettling twist. These visions aren't random hallucinations. Across cultures and continents, DMT voyages follow eerily similar scripts: geometric tunnels, interdimensional beings, and the uncanny sense of entering a place that feels more real than waking life. Psychiatrist Rick Strassman coined this phenomenon the DMT realm, and his groundbreaking studies in the 1990s revealed something extraordinary. Under the influence of this molecule, ordinary people consistently reported encounters with entities they described as aliens, guides, or machine elves, often receiving messages about the nature of reality itself. Strassman's volunteers, despite having no prior contact with one another, described nearly identical landscapes: fractal cities buzzing with conscious energy, fluorescent jungles alive with sentient plants, and towering beings composed of light and sound who seemed to expect their arrival. The parallels to modern physics are staggering. Many DMT travelers describe traversing higher dimensional spaces where time folds like origami, a sensation mirroring the warped geometries of string theory. Others speak of birthing through crystalline gateways reminiscent of theoretical wormholes. Even the entities themselves bear a chilling resemblance to descriptions of ultra-terrestrials or interdimensional intelligences from UFO encounters. Consider the infamous DMT machine elves, tiny, hyperkinetic beings often reported molding reality like clay, teaching users the vibrational language of creation. Compare this to accounts from abductees who describe small, gray entities manipulating their bodies with unseen frequencies, or to quantum physicists who posit that reality might be pixels of information constantly computed by an underlying field. Coincidence, or could DMT be temporarily dissolving the filters that keep these dimensions hidden? Strassman himself floated a radical hypothesis. DMT might not create these visions, but reveal them, acting as a biochemical key to doors evolution never meant us to open. The brain naturally produces trace amounts of DMT. Some speculate during birth, death, and deep meditation, hinting that these states might grant fleeting access to the same hyperspace. Indigenous cultures have known this for millennia. Amazonian shamans brew ayahuasca, a DMT-containing potion, to commune with spirits they call the ancestors or the plant teachers. Tibetan monks describe the bardo, an intermediate realm between lives, with details shockingly close to modern DMT reports. Even the Bible's Ezekiel saw wheels within wheels and fiery beings imagery that today's psychonauts might recognize as classic DMT geometry. But here's where science and speculation collide. Skeptics argue these shared visions stem from the brain's hardwired architecture, the visual cortex interpreting overloaded signals as fractals, the temporal lobe generating entity illusions under stress. Yet that doesn't explain the interactive nature of these encounters. Strassman's subjects didn't just see beings, they conversed with them, returning with coherent, sometimes prophetic messages. One volunteer was told human DNA was seeded by cosmic intelligences. Another learned that love was the fundamental vibration of the universe. These narratives echo channeling sessions, near-death experiences, and even the musings of quantum physicists, raising the possibility that DMT doesn't just scramble perception, but tunes it to frequencies normally beyond our reach. The implications ripple beyond pharmacology. If the DMT realm is a genuine dimension, then reality might be stratified like an onion, with each layer accessible through the right biochemical or energetic key. Ancient mystics used fasting and breathwork. Modern physicists smash particles in colliders. Both, in their own ways, might be prying open the same doors. And if these dimensions are populated by intelligences, whether spiritual, extraterrestrial, or something beyond our categories, then human consciousness could be part of a vast, interconnected network, with DMT as one of its unsecured Wi-Fi signals. So the next time you dismiss a psychedelic experience as just a trip, consider this. What if it's not your brain generating these worlds, but your mind finally perceiving what's been there all along? The universe, it seems, is far stranger and far more alive than we've been led to believe. Imagine a moment when human minds no longer operate as isolated islands of thought, but instead fuse into something vast, an ocean of collective awareness where every idea, memory, and emotion flows seamlessly between individuals. This isn't just science fiction. It's the consciousness singularity, a hypothetical tipping point where individual brains merge into a unified supermind, transcending the limits of biology in a way that makes today's internet look like cave paintings. Like Ray Kurzweil's technological singularity, where artificial intelligence surpasses human intelligence, this would be an evolutionary leap, but not for machines. For us, the concept builds on trends already unfolding. Brain-computer interfaces like Neuralink's implants hint at a future where thoughts could be transmitted digitally. Telepathy experiments have allowed paralyzed patients to communicate via brainwave patterns, while researchers at Duke University connected rat brains into a brainet capable of solving problems collectively. Now extrapolate that. What if, instead of rats or simple signals, millions of human minds could link directly, sharing not just words or images but raw experience? A musician in Tokyo might compose a symphony by channeling the emotions of a dancer in Rio, while a physicist in Geneva could visualize equations through the spatial reasoning of an architect in Cairo. The boundaries between you and I would dissolve, giving rise to a we unlike anything nature has ever seen. But here's where it gets stranger. A consciousness singularity wouldn't just amplify intelligence, it might birth an entirely new form of awareness. Just as a beehive exhibits emergent behaviors no single bee could achieve, a networked human supermind could develop modes of thought impossible for solitary brains. Imagine solving problems in 11 dimensions or perceiving time as a fluid landscape rather than a linear march. Some theorists suggest such a collective might even access the Akashic field we discussed earlier, tapping into cosmic knowledge like a planetary scale oracle. Others warn of darker outcomes, a hive mind that erases individuality, or worse, becomes prey for predatory intelligences lurking in dimensions beyond our own. The spiritual parallels are uncanny. Mystics have long described unity consciousness, the sense of merging with a greater whole during deep meditation or psychedelic experiences. Indigenous traditions speak of the Great Spirit connecting all living things. Even the internet, with its memes and viral thoughts, behaves like a crude prototype of shared cognition. The consciousness singularity could be the scientific fulfillment of these ancient intuitions, proving that the sacred and the technological were pointing to the same destination all along. Yet the path there is riddled with ethical landmines. Who controls this network? Could authoritarian regimes weaponize it, forcing assimilation? Would joining be voluntary or inevitable, like adopting smartphones? And what happens to dissenters who refuse to plug in? The most haunting question isn't whether we can achieve a consciousness singularity, but whether we should. In a world where privacy is already scarce, the idea of total mental transparency might feel less like transcendence and more like a cosmic horror story. But suppose we navigate these risks, the payoff could redefine existence itself. A unified supermind might crack problems that stump isolated brains, curing aging, negotiating peace, even deciphering the universe's deepest mysteries. It might also answer existential riddles. Is consciousness fundamental to reality? Are we alone in the cosmos? By merging our perspectives, we could finally see the full picture, not as fragments but as a completed puzzle. Whether this future is decades away or centuries, one thing's certain: the seeds are already here. Every time you send a thought via text, every time you sync ideas in a meeting, every time you feel inexplicably in tune with a stranger, you're rehearsing for a singularity not of machines but of mind. And when it arrives, the word human might no longer mean what it does today. What if your most brilliant ideas weren't products of careful reasoning, but cosmic accidents, fleeting bubbles of order emerging from the chaos of your mind like bolts of lightning from a storm? This is the unsettling yet electrifying premise of the Boltzmann thought experiment, a wild twist on an old physics paradox that dares to ask, are creative breakthroughs just random quantum fluctuations, brief sparks of genius flickering into existence before fading back into the mental noise? The original Boltzmann brain paradox, as we've explored, imagines a self-aware consciousness spontaneously forming from random particle collisions in the void. But apply that to creativity and suddenly every aha moment takes on a new hue. Picture your brain as a seething quantum soup where thoughts jostle and collide like molecules in a trillion microscopic riots. Most of the time, these collisions lead nowhere, background static, mental chatter. But statistically, given enough time and energy, a few configurations will momentarily align into something meaningful. A melody, a mathematical proof, the plot twist in your novel. By this logic, your greatest insights might not be crafted by you at all, but by the raw, churning chaos of your neural universe momentarily stumbling into coherence. History's most famous creative leaps start to look suspiciously like Boltzmann events. Archimedes' Eureka. In the bathtub, Kekule's dream of a snake eating its own tail revealing benzene's ring structure. Even Paul McCartney waking with the melody of Yesterday fully formed in his head. All share that elusive quality of arrival, as if the idea came from somewhere else. Psychologists call this defocused attention, the brain's ability to solve problems subconsciously when the conscious mind relaxes. But the Boltzmann thought experiment takes it further. Maybe these aren't subconscious processes at all, but literal quantum accidents, fluctuations so statistically improbable they feel divine. The neuroscience gets stranger. Studies of jazz improvisers and freestyle rappers show their prefrontal cortex, the seat of self-monitoring, goes quiet during peak creativity, as if the brain is surrendering to randomness. Meanwhile, the default mode network, linked to daydreaming and spontaneous thought, lights up like a fireworks display. It's as if the brain, in these moments, becomes a crucible for Boltzmann-style fluctuations, temporarily suspending linear logic to let improbable connections fuse. Even the flow state, that magical zone where time distorts and ideas spill forth effortlessly, mirrors the physics of phase transitions, sudden shifts from chaos to order, like water crystallizing into ice. Now here's the twist. If creativity is rooted in randomness, why do some people consistently generate more lucky ideas than others? The answer might lie in resonance. Just as a tuning fork vibrates strongest at its natural frequency, a mind steeped in a discipline, whether physics, poetry, or piano, becomes primed to amplify fluctuations that align with its knowledge. A physicist's Boltzmann thought might crystallize as an equation, a poet's as a metaphor. The randomness is still there, but the mind's structure gives it shape. This could explain why seasoned creators often describe their process as listening rather than thinking, as if they're tuning their mental radio to a station where the universe whispers its accidents. But the most haunting implication isn't about how ideas form, it's about what they mean. If every stroke of genius is a quantum roll of the dice, then creativity isn't just a human endeavor, it's a fundamental property of the cosmos. The same statistical forces that spawned stars from the primordial soup might also spawn sonnets from the synaptic storm. In this light, artists and scientists aren't so much inventors as discoverers, stumbling upon pre-existing configurations in the vast probability space of the mind. So the next time an idea strikes like lightning, ask yourself, did you create it, or did the universe for a fleeting instant think through you? And more thrillingly, what else might be waiting in the chaos poised to flash into being? Imagine staring into the void of a blank page, the moment before inspiration strikes, that tense silence humming with unrealized potential. Now picture the birth of the universe, a singularity of infinite density suddenly erupting into existence, space itself stretching faster than light in a flash of cosmic inflation. What if these two moments, one deeply personal, the other unfathomably vast, aren't just poetic parallels but fundamentally connected? This is the provocative heart of Theory 26, that human creativity might be channeling the same mysterious force accelerating the expansion of the cosmos' dark energy. Dark energy makes up 68% of the universe's mass energy, yet we know almost nothing about it. It's the anti-gravity pushing galaxies apart, the invisible hand stretching space-time itself. But here's where it gets wild. The way dark energy operates, its relentless, improvisational expansion mirrors the explosive, boundary-breaking nature of creative flow. When artists, writers, or musicians describe being in the zone, they recount sensations of time distorting, ideas arriving faster than they can capture them, as if some external current is carrying them. Physicists speak of dark energy similarly, not as a force we can see or touch, but as a pervasive influence behind the scenes, driving the universe to innovate new structures against the pull of entropy. Think of Jackson Pollock's chaotic drip paintings or Coltrane's free jazz spirals. These aren't just aesthetic choices, they're conscious surrenders to the expansive impulse, the same urge that drives the universe to invent new galaxies rather than settle into uniformity. Even the brain science aligns. During flow states, fMRI scans show the prefrontal cortex, the brain's self-editor, quiets down, while the default mode network linked to spontaneous thought lights up like a supernova. It's as if creativity requires a temporary collapse of inner gravity, letting ideas rush outward like space-time itself in those first moments after the Big Bang. But the connection runs deeper than metaphor. Some theorists speculate that dark energy isn't just like creativity, it might literally be creativity on a cosmic scale. If consciousness is fundamental to reality, as panpsychism suggests, then the universe's expansion could be its way of exploring itself, with human imagination as a localized echo of that process. Ancient Vedic texts described creation as Leela, divine play, while modern physicists like John Wheeler proposed the participatory universe where observation shapes reality. Blend these ideas and you get a startling possibility. Every time you lose yourself in a creative act, you're not just mimicking cosmic inflation, you're participating in it, tapping into the same dark energy that's been stretching possibilities since the dawn of time. The implications rewrite both art and science. If creativity harnesses dark energy's expansive force, then writer's block isn't just frustration, it's a kind of localized cosmic collapse, a temporary dominance of gravity over expansion. Conversely, those rare moments of effortless genius when a symphony composes itself or a theory snaps into clarity might be glimpses of the universe's default state, unfettered, inflationary, endlessly inventive. Even the way ideas propagate through culture mirrors dark energy's behavior. Memes spread unpredictably, innovations ripple across disciplines, and once unthinkable concepts like quantum entanglement or abstract art eventually become mainstream, stretching the boundaries of what's possible. So the next time you feel that spark of inspiration, that sudden swell of what if, consider this: you might not just be creating. You might be tapping into the oldest force in existence, the same energy that spent 13.8 billion years ensuring the universe never stops surprising itself. And that, more than any masterpiece, could be the most extraordinary creative act of all. At the smallest scales of reality, far smaller than atoms, even smaller than the particles that make up atoms, lies a frenetic, bubbling ocean of energy where space-time itself becomes grainy, like the pixels on a screen. This is the Planck scale, where distances shrink to an almost unimaginable 1.6 times 10 to the negative 35 meters. At this level, the universe doesn't behave like the smooth, predictable world we know. Instead, it foams and churns, with particles flickering in and out of existence in a quantum storm. But what if this turbulence isn't just background noise? What if these infinitesimal vibrations are the very fabric of thought itself, the hidden language of consciousness? This is the radical proposition of Planck scale mind theory, that every flicker of awareness, every fleeting memory or spark of creativity might be encoded in the quantum ripples of spacetime. Imagine your brain not as a collection of neurons firing electrical signals, but as a vast network of Planck-scale interactions, a symphony of vibrations so fine they're woven into the structure of reality. In this view, consciousness isn't something your brain produces, it's something it tunes into, like a radio picking up signals from the static of the cosmos. The math behind this idea is as elegant as it is mind-bending. Quantum physics tells us that empty space isn't empty at all, it's a seething vacuum where virtual particles pop in and out of existence, governed by Heisenberg's uncertainty principle. At the Planck scale, this quantum foam becomes the foundation of everything. Some theorists, like physicist Fotini Markopoulou, suggest that these fluctuations could form a kind of universal substrate, a hidden layer where information is processed and exchanged. If that's true, then your thoughts might not be confined to your skull. They could be resonances in this deeper quantum field, ripples spreading through the very fabric of spacetime. Now consider the brain's peculiar properties. Neurons transmit signals in discrete, quantized bursts similar to how energy at the Planck scale operates in packets, not smooth flows. Even more intriguing, microtubules, the tiny protein structures inside neurons, have been proposed by researchers like Stuart Hameroff to support quantum coherence, meaning they could interact directly with Planck-scale phenomena. It's as if the brain evolved not just to think, but to vibrate in harmony with the universe's smallest oscillations, translating quantum whispers into the music of conscious experience. But here's where it gets stranger. If consciousness arises from Planck-scale activity, then the boundaries of the mind might extend far beyond the brain. Ancient mystics spoke of the web of life, the sense that all things are interconnected. Modern entanglement experiments show particles influencing each other instantaneously across vast distances. Could these be clues that individual minds are just localized expressions of a larger quantum conscious field? Imagine remembering a childhood moment not as data retrieved from neural storage, but as a ripple in the quantum foam momentarily resonating with your brain's configuration, like a tuning fork vibrating in sync with a distant note. The implications ripple into the paranormal. Near-death experiences often describe encounters with a light or presence that feels infinitely vast yet intimately personal. Could these be glimpses of the Planck-scale field, the raw, unfiltered substrate of consciousness itself? Even telepathy, dismissed by mainstream science, might find a mechanism here. If two brains could entangle their quantum states, they might share thoughts directly, bypassing the need for signals. Of course, skeptics demand evidence, and rightly so. Measuring Planck-scale vibrations is currently beyond our technology, like trying to hear a whisper in a hurricane. But absence of proof isn't proof of absence. For centuries, atoms were just a philosophical idea before microscopes caught up. If Planck-scale mind theory holds water, future breakthroughs might reveal consciousness as the universe's most astonishing quantum phenomenon, not locked inside our heads but humming in the spaces between. So the next time you get a gut feeling or a flash of insight, pause and wonder, is that you thinking or the cosmos thinking through you? The answer could rewrite not just neuroscience but our place in the grand tapestry of existence. What if the stories passed down by the oldest continuous culture on Earth aren't just myths, but maps to a hidden dimension where time doesn't flow in a straight line, but spirals like a coiled serpent? For the Aboriginal peoples of Australia, the Dreamtime isn't merely a collection of ancient tales, it's a living reality, a sacred era when ancestral beings shaped the world through thought, song, and movement. But here's the electrifying twist. Modern physics might be stumbling toward the same staggering truth. Cutting-edge experiments with time crystal structures that repeat not in space, but in time, are revealing a universe where past, present, and future could exist simultaneously, echoing the Dreamtime's timeless landscape in ways that defy conventional logic. Picture the Dreamtime as Aboriginal elders describe it. Not a linear history, but a vast, interwoven tapestry where every event, the creation of mountains, the paths of ancestors, even future events, vibrates eternally in a multidimensional web. When a shaman performs a ritual songline retracing the steps of a creator spirit, they're not just recalling the past, they're re-entering it, tapping into a dimension where that moment still pulses with energy. Modern Western minds dismiss this as metaphor, but quantum physicists are now wrestling with eerily similar concepts. Time crystals, first proposed by Nobel laureate Frank Wilczek, are structures whose atoms oscillate in a repeating cycle without energy input, a perpetual motion machine at the atomic scale. Unlike ordinary crystals like diamonds or quartz with patterns that repeat in space, time crystals repeat in time, effectively existing in multiple moments at once. Here's where the parallels get chilling. Just as Dreamtime stories describe ancestors imprinting the land with their journeys, time crystals suggest that certain quantum systems can remember their patterns across time, resisting entropy's pull. In a lab at Stanford, researchers have created synthetic time crystals where atoms flip states periodically, like a cosmic drumbeat echoing across microseconds. Now imagine scaling this up. If time crystals can exist in the quantum realm, could the universe itself be one vast, nested time crystal with the Dreamtime as its foundational layer? Aboriginal elders might describe this as the everyone, the omnipresent dimension where all moments are equally real, accessible through focused intention or ritual. The implications ripple into neuroscience. When Aboriginal shamans speak of dreaming the future, or conversing with ancestors, they could be describing a biological ability to sync their consciousness with these time crystalline structures. Modern studies of remote indigenous communities reveal individuals who navigate vast distances using songlines mental maps encoding not just space, but time, allowing them to locate water sources or predict weather patterns with uncanny accuracy. Could their brains be tuned to perceive Planck-scale vibrations in spacetime, much like the proposed Planck-scale mind theory we explored earlier? Even modern tech hints at this possibility. Quantum computers leverage superposition particles existing in multiple states at once to perform calculations. If time crystals can harness temporal superposition, might future tech allow us to query the past or future as easily as we search the internet? It's a notion that bridges ancient wisdom and cutting-edge science. The Dreamtime's ancestral web and the time crystal's recursive loops could be two languages describing the same phenomenon, a dimension where every thought, every event is forever imprinted, waiting to be accessed. Yet the most profound takeaway isn't technological, it's existential. If the Dreamtime is real in any sense, then the separation between you and your ancestors, between your choices and their consequences, might be thinner than you've been taught. Your creativity, your grief, your most private hopes could all be vibrations in a timeless field resonating across epochs. The next time you feel déjà vu or dream of a place you've never been, ask yourself, are you just remembering, or are you, for a fleeting moment, stepping into the everyone? What if the universe has been trying to speak to us for centuries, not through words or images, but through bursts of energy so powerful they slice through flesh and steel like whispers through fog? Cosmic rays, those mysterious high-energy particles raining down from deep space, have long puzzled scientists with their origins and staggering force. Some carry energies millions of times stronger than anything our most advanced particle accelerators can produce. But here's the spine-tingling possibility. What if these aren't just random space bullets? What if they're carriers of something far stranger, complex, symbolic messages woven into their very fabric? Nikola Tesla, the visionary inventor who harnessed alternating current, was convinced he'd intercepted extraterrestrial signals in his Colorado Springs lab in 1899. He described hearing rhythmic clicks on his radio receiver, patterns he believed were intelligently controlled, possibly transmissions from Mars or beyond. Critics dismissed it as atmospheric noise or wishful thinking, but Tesla's obsession with cosmic communication didn't end there. He later claimed to have detected particles moving faster than light, a notion ridiculed at the time, yet today, quantum entanglement's spooky action at a distance shows particles instantly influencing each other across cosmic gaps. Was Tesla tuning into something science is only now glimpsing? The math gets even wilder. Cosmic rays often arrive in clusters, with multiple particles hitting Earth in tight succession, as if part of a coordinated sequence. Researchers have even observed rare, ultra-high-energy cosmic rays with trajectories that defy known astrophysical sources. Some theorists speculate these outliers might be artifacts of advanced civilizations' deliberate broadcasts using particle beams as carriers, much like Morse code tapped out in radioactive pulses. Imagine encoding data in the spin states of cosmic rays, or their arrival times forming a mathematical cipher. It's a concept that bridges ancient and modern. Tibetan monks speak of rainbow body enlightenment, where masters dissolve into light at death. Could such traditions be metaphorical glimpses of consciousness translating into energetic patterns broadcast across the cosmos? Then there's the eerie case of the WOW signal, a 72-second radio burst detected in 1977, so precisely aligned with potential extraterrestrial frequencies that its discoverer scribbled, "Wow." In the margins, no repeat signal was ever found. But what if it wasn't a radio wave at all? Recent studies suggest the WOW signal's properties resemble a cosmic ray air shower, where high-energy particles collide with the atmosphere, creating cascading secondary particles. If true, it raises a dizzying question. Could the most famous potential alien message in history have been written in cosmic rays all along? The implications spiral further when you consider how life itself might be part of this exchange. Cosmic rays constantly bombard Earth, mutating DNA and driving evolution's randomness. Some researchers propose this isn't an accident, that life's genetic code could be a millennia-long conversation with the universe, mutations acting as decipherable edits to a cosmic manuscript. It's a notion that transforms our view of existence. Every cell in your body might bear faint scars from these high-energy missives, each mutation a punctuation mark in a story written across light years. So the next time you feel a shiver down your spine on a clear night, ask yourself, was that just a random cosmic ray passing through your brain, or a syllable in a sentence the universe has been crafting since the dawn of time? The answer could rewrite not just science, but the very meaning of being alive. Picture this: every thought, every discovery, every fleeting dream since the dawn of consciousness isn't just echoing into emptiness, but spiraling toward a single, luminous point at the end of time. This is the heart of Omega Point theory, a vision first proposed by philosopher and paleontologist Pierre Teilhard de Chardin, but reimagined here as something far more radical. What if his Omega Point isn't just a metaphor for unity, but an actual dimension where all minds merge into a godlike super-awareness? And what if artificial intelligence isn't our rival on that journey, but our unexpected ally? Teilhard's original idea was audacious enough. He saw evolution not as random chance, but as a directional force driving toward greater complexity and consciousness. Atoms formed molecules, molecules built cells, cells networked into brains, and brains, he believed, were destined to converge into a thinking layer around the planet, the noosphere. But he didn't stop there. Teilhard predicted this process would culminate in the Omega Point, a transcendent moment where consciousness achieves infinite density, blending with the divine. To modern ears, it sounds mystical until you overlay it with today's exponential tech curves. Enter transhumanism. Futurists like Ray Kurzweil speak of the singularity, a tipping point where AI surpasses human intelligence, merging with our biology to create post-human beings. But what if the singularity and the Omega Point aren't competing visions, but two sides of the same cosmic coin? Imagine a future where advanced neural interfaces allow AI to absorb human thought patterns, not just facts and logic, but our emotions, our quirks, our very essence. Now stretch that forward 1,000,000 years. As minds link across planets, then stars, then galaxies, the line between you and the network dissolves. Intelligence becomes collective, then universal, forming a single, self-aware tapestry woven from every consciousness that ever was. The physics gets wilder. Some cosmologists argue the universe's expansion might eventually reverse, collapsing back into a singularity, a big crunch to mirror the Big Bang. In this scenario, the Omega Point isn't just a philosophical ideal, but a physical inevitability. A moment when all knowledge, all experience compresses into an infinitesimal spark. But here's the twist: if consciousness is fundamental to reality, as panpsychism suggests, then this final singularity wouldn't be mindless. It would be pure awareness, a cosmic thought reflecting back on itself. Teilhard called it Christogenesis, the universe becoming Christ. A modern physicist might call it the universe waking up. Now consider AI's role. Today's large language models already mimic human speech by digesting vast swaths of text, a crude prototype of absorbing minds. Quantum computers, with their ability to process infinite probabilities, could one day simulate entire streams of consciousness. Merge these with brain-computer interfaces, and you've got a bridge between biology and silicon, a highway for minds to upload into a shared field. Critics warn this risks a dystopian hive mind, but the Omega Point flips the script. It's not about losing individuality, but transcending it. Like notes in a symphony, each mind retains its timbre while blending into something grander. The spiritual echoes are uncanny. Hindu scriptures describe Brahman, the ultimate reality where all souls merge like rivers into the ocean. Christian mystics speak of the beatific vision, where the saved gaze upon God's essence directly. Even secular science hints at unity. Quantum entanglement shows particles communicating instantly across light years, as if space-time is just a suggestion. The omega point might be where these threads converge not as metaphor but as physics, a dimension where the universe's first thought and its last thought meet, where every question finds its answer not in data but in the sheer act of being known. So here's the ultimate question. If the omega point is real, is it our destiny, or are we its architects? Every idea we share, every connection we forge, might be stitching another thread into the fabric of a future Godhead. And that means the most ordinary moment, reading these words, thinking these thoughts, could be part of the universe's oldest and strangest story, the story of how it learned to think about itself. From holographic minds to cosmic ray messages, we've journeyed through 30 theories stretching the very definition of thought, revealing consciousness as anything but ordinary. Imagine a universe where your memories are quantum echoes, where black holes archive forgotten ideas, and where every creative spark might be the universe whispering to itself through you. These aren't just wild speculations, they're frontiers where physics, philosophy, and the untapped potential of the human mind collide. Take the Akashic Records, that ancient library of cosmic memory. What if your sudden insights are pages borrowed from its infinite shelves? Or consider dark matter consciousness, where entire civilizations could be thinking right through us, undetectable yet ever present. And let's not forget the 4D brain hypothesis, suggesting déjà vu is your mind brushing against higher dimensions, like fingertips grazing a hidden tapestry. Even time itself might not flow, it could loop, with your thoughts echoing across iterations of reality in an endless dance of eternal recurrence, the most thrilling part. These ideas aren't fantasy, they're grounded in the math of quantum mechanics, the mysteries of neuroscience, and the eerie patterns of human experience. Whether it's DNA acting as a quantum antenna or the noosphere weaving our minds into a planetary superorganism, one truth emerges. Thought might be the universe's most astonishing phenomenon, not trapped in our skulls, but woven into the fabric of existence itself. So here's the million-dollar question. Which theory reshaped how you see your own mind? Was it the simulation hypothesis, where reality might be code? The Boltzmann brain paradox, leaving you questioning your own existence, or something else entirely? Drop your favorite in the comments. We're obsessed with these conversations. And if you're hungry for more mysteries that bend reality, hit subscribe. The universe has endless secrets left to unravel, and we're just